Society has evolved a lot since the beginning, from kingdoms to empires. Nowadays, most countries in the world elect their own leaders. But is the way elections run truly the best? There are many ways elections are held around the world. The most simple one is called first past the post, where people choose the candidate they like the most and the candidate with more votes is the winner. This method is mostly used in former British colonies like the US or Canada.
One of the biggest problems this method has is that you will most likely end up in a situation where the majority of the population didn't vote for the elected leader.
As a matter of fact, in the last 100 years in the UK, there has been 21 times where a single party held the majority of the parliament seats, but only 2 of those times did the majority of the voters actually vote for said party. In order to reach majority, some countries, like mine Peru, hold a second round of elections, where if no candidate actually reach 50% plus 1, then those who end up first and second goes to the next round. You could even be more detailed and ask people to rank their candidates. So instead, when the first round passes and no one wins, then the candidate with the least votes has theirs distributed based on the people is number 2, and so on until one candidate remains. This is called instant runoff, and countries like Ireland and Australia use it, though the latter is for their parliament, not presidential votes. However, this breeds a bigger issue. Imagine candidate A got 27%, candidate B got 30%, and candidate C 43%. A and C are total opposites, while B is somewhere more in the middle of the political spectrum. A is eliminated, but everyone chooses B as their second choice due to C being too extreme, making B the winner. But now, imagine that C made some hate speech that makes some of their voters goes to A. Now B is eliminated, and because they are more neutral, half of his voters goes to one another, making C the winner. So by doing worse in the first round, candidate C actually end up winning, and obviously no one wants this to be an opportunity. For centuries, many mathematicians argued the way to make voting more fair, from Nicolas de Condorcet to Lewis Carroll, all came to their own hypotheses, but none could reach a real solution. It wasn't until 1951 when Kenneth Arrow established in his PhD thesis 5 conditions that any voting system should have. Condition 1. If a whole group decides on one thing, then the results should reflect it. In other words, you need unanimity. Condition 2. No vote should override everyone else's preference. If the opposite happens, then it's no democracy, it's a dictatorship. Condition 3. Everyone should vote however they want, and the system must conclude a solution based on all the ballots every time. It can't avoid problematic ballots nor candidates. This is called unrestricted domain. Condition 4. Transitivity. If a group prefers KFC over McDonald's and McDonald's over Burger King, then the group should also prefer KFC over Burger King. Condition 5. If a group prefers KFC over McDonald's, adding a third option shouldn't change this. Sure, you can add the new option in any position, but KFC should still be over Burger King. This is called independence of irrelevant alternatives. But here's the catch. Arrow concludes that satisfying all these 5 conditions in a ranked voting system with more than 2 candidates was impossible. This is known as Arrow impossibility theory and granted him a Nobel Prize in 1972 in economics. Here is an example of this. Imagine we have candidate A, B, and C, and we have a collection of voters, voter 1, 2, 3, and so on. First, I want to show that if the voters choose a candidate first or last, then society as a whole should also rank them first or last. Let's say candidate B. If half of the voters put B first and the other half put B last, then B will rank second in society's voting, making a contradiction. Because if each of our voters move C above A, then by unanimity, C must rank above A in society's voting. However, because we never change the position of any A relative to B, A must still rank above B, and because we never change the relative position of C and B, C must still rank below B, and by transitivity, this means A should be above C, contradicting the result of unanimity. Now let's do an experiment where every voter chooses A and C over B. By unanimity, we know that B must be at the bottom. Now imagine that voter 1 moves B to the top, and then voter 2. If we keep doing this, we will reach a voter whose change will flip society's voting. Let's call them the pivotal voter. Now let's create another scenario where the pivotal voter moves A above B. By independence of irrelevant alternatives, the social rank should also vote A above B, since for any other voter, the relative position of A and B is the same as it was before. And B should be above C, since the relative positions are the same as they were before in the previous scenario. And by transitivity, A should be above C regardless of how the other non-pivotal voters arrange the position of A and C, since the position between A and B and C never change. This makes the pivotal voter a dictator.
Does this mean democracy is doomed? Well, not exactly. Arrow's theory only works in rank systems, but there is another way.
Instead of ranking candidates, one could also rate them. Say 10 points to those who you approve the most, and minus 10 to those who you disapprove. Rated voting systems is, for example, used to choose the next Secretary of the UN, but it's not really popular for presidential elections, so more practical research will be required to determine its pros and cons.
So, is democracy doomed? Well, yes and no. It might be impossible in our current voting system, but that doesn't mean we should stop trying. The system is not perfect, quite the opposite, but not many can argue that it hasn't improved since the days we used to elect a king based on the position of the stars.